when you studied physics in Science 10, you studied, for the most part, kinematics, a branch of physics called kinematics. Kinematics is the study of motion. But there's another study of motion as well called dynamics. Kinematics is the study of motion without regard. Do you know what I mean by that? Without regard? Means not paying any attention to, right? Without regard to what causes the motion. So we're going to study just the motion itself. Got it? Next unit is dynamics. We're going to study motion with regard to what causes the motion. In other words, in the next unit, we're going to study, do you know what causes motion? Kinda. Forces. We're going to study forces in the next unit. We're not going to even mention the word force in this unit, though. We're just going to study the motion itself. Not what causes it, just the motion itself. So we'll say this is the study of motion without W-O, do you know that? Without regard to the cause, the motion itself. Now, before we really get into the motion, we have to understand the difference between two terms, vector and scalar. You've done this before in Science 10. This isn't new to you, but you might forget it. A vector quantity, a quantity is something like kind of like a measurement, like distance would be a quantity, speed would be a quantity, acceleration would be a quantity, force would be a quantity, even though we're not going to talk about force in this unit. A vector is a quantity that, you guys know the difference? Scalar is a quantity as well, so what's the difference? A vector is a quantity that? Ooh, the big one. Both magnitude and direction. A scalar is a quantity that has only magnitude. And a vector is a quantity that has both magnitude and direction. Does that ring a bell? It's easy to get those mixed up, though, right? It's easy to get those mixed up. Like, I got a terrible memory for things like this. I remember that because I've done it a million times before, right? But if I was seeing this for the first time, I probably wouldn't remember tomorrow the difference between a vector and a scalar. It's easy to get those things mixed up. I got a way for you to remember, maybe, hopefully. Years ago, I was shopping at grocery shopping at No Frills. And I was in the cereal aisle, and I was a little bored and distracted, I don't know, and I was reading the labels for these different cereal boxes. I don't know. I came across vector cereal, or vector meal replacement it is. It's not cereal, it's meal replacement. That's what they call it anyways. And I was curious, I wonder what the difference is. Like, I wonder if there's really a difference. They market it as vector meal replacement versus vector cereal. But I wonder what the difference is. There's not much of a difference, by the way. I read the label, and it's not much of a difference at all between, say, cornflakes and vector cereal, nutritionally. A little bit, but not much. But what struck me was not how similar vector cereal is to, vector meal replacement is to other types of cereal, but what struck me was every single cereal, and I checked this after I saw this box and read this, I checked this. Every single cereal in the aisle, every single one tells you how much is in it, the magnitude, right? 400 grams, 600 grams, whatever. That's magnitude, right? Okay, that's how big it is. That's how big the box is, how much it is. Doesn't tell you anything about direction. Every single box had magnitude. But vector cereal, vector meal replacement, the only box in the aisle, and I swear, like, check this. Go check the cereal aisle at the grocery store. Vector cereal, the only cereal that has on the side of it right here, what does that say?
Directions for use.
Directions for use. Now, just in case you're not sure, this is how you eat vector cereal. Place 55 grams of vector, that's 1 1/4 cups, by the way, in a bowl. Add 3/4 cups of milk. That's what it says. Look, that's what it says. Place vector in a bowl, add milk. Doesn't say what to do next. This isn't the kind of direction we're talking about here with a real vector, right? Like we're talking about north, south, east, west, right, left, up, down, right? This is the way to remember it, right? If you get mixed up between a vector and a scalar, vector serial is the only one with magnitude and direction, right? Vector serial has direction. Scalar serial, like cornflakes, doesn't have direction. It has only magnitude. Got it? Okay, difference between a vector and a scalar. Now, let's define a couple more terms here. Distance. Who can define distance for me? Like this is one. Like, it doesn't matter if you've ever defined this in physics class before. You know what distance means, right? Yeah. Yeah, how far something's moved. That works for me. How far something moves, or has moved, whatever. Now, sometimes you see a symbol for distance that is just a d. We don't usually use just a d. You could, but usually for distance, we use a little triangle d. Do you know what that triangle means? Yep, Tyler? It means change, right? It's a Greek letter, delta. It means change. When you have a number that represents how far something has traveled, that's kind of referring to a change, right? Where it's been has changed. So usually we call it delta D. Now there's all kinds of units that we can use. Units, by the way, do you know what a unit is? Sometimes on the first day I forget that you might not know what some of these terms mean. You know what a unit is? What's the unit for temperature? A couple weeks ago it was minus 37 degrees Celsius. Degrees Celsius. So that's the unit for temperature, right? What's the unit that we would probably use for distance? There's a bunch of them we can use. But what's the standard one, Jack? Yeah, meters. Now, there's a lot of times when we actually can use kilometers or miles or inches or centimeters, but the if in doubt unit, what I mean by that is, listen, if you're not sure what to do, if in doubt, go meters. Because meters always works. Sometimes other units work. Meters always works. And finally, the distance is a vector or scalar. Yeah, the distance between Okotoks and downtown Calgary is 39 kilometers. We don't put a direction with that. The distance is 39 kilometers. So distance is a scalar. It's the cornflakes of kinematics. There's no direction. Let's find a couple more and take a quick little break. What's position? What's position? Yeah, that's...
Where something is
yeah.
relative to something.
Yeah, good, good. Where something is, but it's not, like, let's say it's grade 7, let's make it grade 11. Grade 11 dance, okay, at school. I know you guys don't go to the dances. It's grade 11 dance, and all the boys are on this side of the room, all the girls are on this side of the room, and one of the boys over here, who wants to be a volunteer? Nobody? Okay, Jacob. Jacob's on this side of the room. He's hanging out with... No, you don't have to actually go anywhere. Just want to use your name, Jacob. He's on this side of the room. He's hanging out with his buddies. And he's like, who wants to be the girl volunteer on this side of the room? You don't have to go anywhere. Nobody? Okay, we'll call her Jane. Jacob? Jane. Jacob sees Jane on that side of the room, and he's like, oh, Jane's kind of cute. Jane sees Jacob on that side of the room, and he's like, Jacob's kind of cute. Jacob finally gets up the nerve to ask Jane to dance, and they dance the night away, and they have a blast, and Jacob says, hey, like, you want to go to a movie? Jane's like, yeah, sure. And Jacob says, how about Saturday night? Jane says, yeah, that's great. And Jacob says, I didn't know where you lived to pick you up, where to pick you up. And Jane says, well, Jacob, on Saturday night at 6 o'clock, my position will be 27 kilometers. Jacob's like all happy, goes home and like, wait a second, that doesn't help me at all. If I want where she is on Saturday night to pick her up, I need magnitude and direction, right? So position, where something is, by the way, that's not enough either though. Where something is with the direction, 27 kilometers to the north of what, right? What did you say, Beth? Relative to something, right? So where something is relative to something. Relative to a reference point or relative to something else. It's a vector because it does have a direction associated with it. Right? Jacob sends a message to Jane that's like, I'm sure it was just a mistake. I'm sure like you meant to give me the direction because I'm sure you wouldn't have just been trying to ditch me like, you know, I live 27 kilometers, but she messaged him back, yeah, it was just a mistake, Jacob. I meant to tell you where I live exactly. We need that direction, right? We need that direction. What's the symbol for position? Where something is? Where something is? It's a D. There's no delta there, right? Her position hasn't changed. This is where she is. But there is a little arrow over top of it. It's a little half arrow, actually. You guys know what that half arrow means? Nope. No. If you don't have the delta, then that means it's a number that's, that number per se isn't changing. That arrow doesn't have anything to do with changing or not changing. That arrow is kind of staring you in the face up there already. The answer to this question. The arrow means that this quantity is there's a direction associated with it. It's a vector, right? And the units for that would be meters. Displacement. I'll just define that one. This is defined as a change in position. So Jane's position was 27 kilometers north of Dairy Queen. Then her position was 29 kilometers north of Dairy Queen. Her displacement is her change in position. So her displacement would be 2 kilometers north, right? The change from 27 to 29. That's going to be a vector because position's a vector. The units are going to be meters. Anybody for the symbol there? Oh, you can get this. Come on. Position is D with the arrow over it. What would displacement, the change of position, be, Tyler?
So it'd be a delta before the D.
Yes, delta before the D, because that's change, right? Position is D with the arrow over it. So delta D with the arrow over it would be change in position or displacement. Finally, one more, time. Time, man. I should have just blanked this one out. Everybody knows what time means, right? You guys all know what time is. Like time is that quantity that, man, like everybody knows what it is, but nobody can define. Like I've tried so hard over the years to come up with a good definition of time, but nothing really makes any sense. Like nothing helps us to understand time more than how we already understand time. We're not even going to define that. I don't want to define it. You know what the symbol for time is? What do you think the difference is there? Not a fixed period of time. You were almost right there. You said that word period there. If I look at my watch and say it's 9:33, oh, we're like 10 minutes past break time. 9:33, that's T. That's what time it is, right? At a moment, at an instant, that's what T is. But if I said, and like I will in just a moment here, go take 3 minutes, go get a drink or whatever, 3 minutes is not what I would read on my watch. 3 minutes is an interval of time, right? A change in time. That make sense? If I let you go at 9:34 and tell you to come back at 9:37, 9:34 is a t. 9:37 is a t. 3 minutes is a delta t, a change in time, right? What do you think the units for time are? Oh, you could use hours or minutes or years, but usually we use seconds, and time is a scalar. Your break right now is 3 minutes, not 3 minutes to the north, because that would be a vector, and that would be silly because time is a scalar. All right, let's take a look at how we can find displacement now. All these other things are just numbers, right? That like this is where I am. This is how far I've traveled. This is what time it is. A displacement is one that we actually have to find. This is where I am. This is where I was. What's my displacement? How are we going to define displacement? There's actually two ways to find displacement, and it depends upon what you're given. Displacement, remember, is delta D with the arrow over it. We can find the total displacement by adding displacements. So in other words, if we have two different displacements, like a guy walked 10 kilometers to the north, then he walked 5 kilometers to the north, we would add those two numbers together to get the total displacement. If you have two displacements, add them together to get the total displacement. The other way to find displacement is to subtract positions. The final position minus the initial position. So be careful here, right? Guy walked 10 kilometers north, then he walked 5 kilometers north. We add those together to get 15 kilometers north. But you can imagine if, look, the guy was 10 kilometers north of Dairy Queen, and then he's 5 kilometers north of Dairy Queen. That's not how far he's walked. That's his positions, right? That's where he is and where he was. We don't add those numbers together. If he started at 10 and then he ended up at 5, he hasn't walked 15. And we don't add those together. We subtract them. So if we have displacements, we add them. If we have positions, we subtract them. So it's important when you get a problem, like you're going to see in just a moment, to identify what you've got. Like each number, is this where I am? Or is this how far I've gone? Position or displacement. And if it's positions, then make sure you subtract the two numbers, the final minus the initial. That's what that means, by the way, right? df minus di. Okay, final minus initial position. Doesn't matter what you did in between, final minus initial position. Or if you've got displacements, you add them together. By the way, displacements, there could be 3 or 4 of them as well, right? Delta D1 plus delta D2 plus delta D14, if you have 14 different displacements that you have to combine. Okay, we're going to do a couple examples here, and then I'll let you work on a few questions. This seems easy so far, doesn't it? Let's take a look at example number 1. It's in your booklet. It says, if you walk 20 meters east, then 20 meters west, your distance traveled is blank, and your displacement is blank. What do you got here? Are these positions or displacements? 20 meters east. Is that where this person is? Or is this how far this person's walked? Yep. Yeah, those are displacements, right? So if we've got displacements, what are we going to do? Add or subtract? Yeah, you're going to add them together, right? To find the total displacement, we're going to add these guys together. Delta D1 plus delta D2. Again, if it said walk 20 meters east, then 20 meters west, then 10 meters west, then it said it walked 50 meters to the east again and 20 meters to the west again. We just add in delta D3 plus delta D4, right? Just keep adding them in as long as you go. Just hold off before you write any more. Okay, what you have right here is good if you've already written this down, but don't write any more right now, okay? Just watch me for a second, okay? What's delta D1 here? I'm finding displacement right now, not distance. I'm finding displacement, okay? You can see that because I've written the little half arrow over top of it, right? That's displacement. What's delta D1? What's displacement 1? Yep, 20 meters, okay. What's displacement 2? What is it? Yes. So what we're going to do every time we see a problem involving directions is assign a positive and assign a negative. We're going to say east is positive here. Usually east is positive, west is negative. You could do it the other way around. That would be okay. It's just not normal. It's not typical, but it's okay. If we make east positive, then delta D1 is positive 20 meters. We make west negative. Then this 10 meters is, what should it be? Yeah, it's negative 10 meters. Now, we're adding, right? But we're adding a negative number, which is like subtracting. But I want you to think of it as adding. Okay, think of it as adding. 20 plus negative 10 is, what is that, 10 meters? What does that mean? 10 meters, I got a positive there. 10 meters to the, yeah, you know what? You don't actually have to write the east. If you write a positive here, you don't actually have to write an east. How come? I already defined east as positive up there, right? That's my little key up there. So I'm going to say my displacement is 10 meters to the east. This is a word problem that's not kind of a blank, fill in the blank like this, and you wrote it like this, that would be absolutely fine without writing the word east in. It's okay to write east as well, but you don't have to, as long as you've done this. Hey, what would the distance be? Ooh, this one's, what would the distance be? What is it? Why is it different? Why is it different? Yeah, like distance is a scalar, it has no direction. So it's going to be delta D1 plus delta D2. It's 20 meters plus negative 10? That's just 10, right? Oh, that's a positive, so that means to the east as well, right? No. The positive means nothing there. You wouldn't get a negative there, but positive means nothing because it's scalar. There is no direction. Listen carefully to this, guys. If you can imagine if I had to walk 20 meters east and then 10 meters west, then 10 meters east, then my displacement would be 30, my distance would be 30. Same number, right? Here we've got two different numbers. What's the difference? When I don't change direction, my distance and displacement will always be the same number. Always be the same number. But if I change direction, then the number is different. Does that make sense? As soon as you change direction, the number is different, like it is right here. Okay, let's take a look at, I think it's just one more example, and we'll let you work here. This one says, if your initial position is 100 meters to the south, and your final position is 150 to the north, what's your change in position? Your change in position, okay. Let's make north positive here. Could you make south positive? Yeah, you could. I don't know why you would, but you could. What do we have here? Initial position is, it's kind of an easy one because it actually uses the word, right? Is this where I am? Or is this how far I've gone? This is where I am, right? This is position. My initial position is, I'm going to write this down here so I don't get confused, is 100 meters. And my final position is 150 meters. Is that right? Is that right? Yeah. Yeah, negative 100 meters. How do I find change in position? Isn't that the same thing as displacement? This is the same question, isn't it? My change in position is, I'm finding one thing, right? My displacement, my change in position is either add displacements or subtract positions. In the last question, we added displacements. In this one, we're subtracting positions. So we're going to say 150. Ooh, forgot this was going to happen. 150 minus 100. 150 minus negative 100. Somebody said use brackets there. You actually don't need brackets there, but sometimes maybe it's a little bit easier to see what's going on if you have them. What's 150 minus negative 100? 250 meters. I already defined north to the as positive, so this would be 250 meters to the north. If you're just writing it like this, you don't need the word north, but you can say 250 meters to the north, and of course my displacement would be the same thing. What would be my distance traveled here? Just out of curiosity. Didn't ask you that there, but what would it be? It's 250. Did I change direction? Did I change direction? No. No, look at this. I started in one spot, and then I walked or ran or whatever to another spot. Did I change direction? No. Like, I got a north and a south, but I walked the same way the whole time, right? So my distance would be the same number as my displacement in that case. Does that make sense? Okay, good. We did it with like 9 minutes to spare, even with going through the syllabus and all that stuff. Going to get you to take a look at worksheet number 1 right now, please. Worksheet number 1.